Chapter 7 kind of continues the theme from Chapter 6 and talks about another way that we can evaluate economic policy or really any kind of policy in terms of its effectiveness and sort of benefit versus cost. And so this is a cost benefit analysis, which is exactly what it sounds like. We're going to look at the costs of a particular project or a particular policy and weigh that against the benefits of that policy and if the benefits outweigh the costs, assuming we've measured everything well and correctly uh, and fully, then sure, it's a policy we should go forward with. So here's just an example that the book starts off with of what a cost-benefit analysis looks like. This is a cost-benefit analysis of proposed ozone standards in the United States relative to a baseline standard. If we change those standards, what would that look like? And so they list here the different costs, three different possible new standards and what those costs and benefits would be. Notice each of them has a range of possible costs and benefits because it's not, as we'll see as we go through this chapter, necessarily simple to nail down what the exact figures are here. So one of the issues in a cost-benefit analysis is figuring out the value of money in the future, because almost any policy that you're talking about is not a policy that's only going to have an effect today, but hopefully it's something that will have an effect down the road. And so benefits may occur later. Also, costs could occur later. So if we're talking about something like building a dam, for example, oftentimes you finance that. It's a huge cost to build it to start with, and you may finance that and have some cost that you're still incurring several years down the road from the construction project. And so it's important to be able to understand the value of money tomorrow when we're thinking about a policy that we might enact today. And we've talked about this in a previous chapter. We just sort of renew the discussion of present value. So present value is calculated here. The present value of some amount of money in years down the road. So N stands for how many years from now we're talking about. So is you take that amount of money and you divide it by 1 plus R raised to the N. Again, that N is how many years down the road. So the XN on top is how, so say you're planning to get $100 benefit 10 years from now, then XN would be 100 and N is 10. Right, so XN is how much money you get 10 years from now, or in years from now. So this chapter goes into some of the difficulties with figuring out what that R is. So the R in that equation, oftentimes in a lot of classes, if you had finance classes, for example, will simplify R to just be the interest rate or rate of return on investment if we were to put this money in a stock market. So if you think about, I'll give you $100 10 years from now, I might think to myself when I'm thinking about what the value of that money is, think about how much could I have earned from the stock market or from a bank account, a savings account with that money if I had it today instead of 10 years from now, right? So that interest rate or rate of return on investment is part of R there, but R really is larger than that. So we call it discount rate because it's not just an interest rate. It's a total picture of how much future money is discounted, right? And so it includes the interest rate or return on investment because certainly future money that you give me tomorrow is not as valuable to me as money you give me today, because if you gave it to me today, I could earn money on it based on that interest rate or return on investment between now and that future time, right? But it's also not as valuable to me tomorrow as it is today for other reasons. So there's also this social rate of time preference, and your book goes into some of the math of it. That's not as important really as just understanding conceptually what it is. So the social rate of time preference that also contributes to what that discount rate will be includes our preference for obtaining benefits now versus later, and that separate of any interest rates or any return on investment, that could be That could be huge. And it depends on who you are, right? So you can think about someone who already has $1 million. If you tell them, I'll give you $100 today or $100 tomorrow, they may not care the difference between today and tomorrow. But someone who has very little and has to pay the water bill today, that $100 today may be much more valuable to them than waiting till tomorrow to get it. Right? Even if you told them, I'll give you $100 today or $200 next year, right? Even if it's more next year, they still might have that preference to accept fewer dollars today rather than wait till another time to get more money just because of their preference for benefits now versus later. And then there's this other piece of the social rate of time preference, which is our changes in standard of living, or the value of money between now and later. If economic progress continues, then people generally will be richer several years down the road than they are today. And as we just discussed, the value of money to a rich person is different from the value of money to a poorer person. And so the value to me of $100 10 years from now may be different than the value to me of $100 today, just because 10 years from now I may be richer. I may have a higher standard of living. So there are several, these are some, and then you can maybe think of some other things that would cause people to have different discount rates, for the value of money today versus tomorrow. But all of these things sort of have to be built into what that R is in calculating present value if we're going to accurately predict the present value of money. And that becomes important when we're evaluating policy that may have benefits down the road or costs down the road. It becomes important to really understand what is the value of that benefit. Um, so there's actually some controversy in how we calculate that discount rate, and different economists and others have tried to calculate a different discount rate and have really gotten vastly different numbers for it. You can read more about that, and it just depends on how we calculate it, what kinds of things we include, and how we try to measure these these uh, these preferences, right? But it's important to at least keep in mind that this is part of that R and part of determining the value of money. So then you have these examples of how important it is. How important is that discount rate? If we decided the discount rate is 1%, we'd get a very different number than if that discount rate is 10%, right? So this table shows the future value of $100 given to us today, right? So 0 years into the future. So right now, that $100 is worth exactly $100, regardless of what the discount rate is. And then if we think about 10, 20, 30, 50, and 100 years from now, the value of receiving $100 that long from now, so the value of receiving $100 10 years from now, if the discount rate is 1%, is 90.53. If the discount rate, however, is 10%, the value of getting $10 or to getting $100 10 years from now is only $38.55. Right. So it's really important, and you can see how that changes 100 years from now. If I tell you I'll give you $100 100 years from now, and you're trying to think about what's the value of that to me today, it depends on what the discount rate is. If the discount rate is very small, the value of that could be $36, $37. If the discount rate's pretty large, the value of that could be nothing. And so this table and then the graph on the next slide, which just graphs those exact same numbers from the table, shows the declining value of money over time depending on what that discount rate is. And that just shows sort of the importance of understanding what goes into that discount rate and how we calculate it when we're trying to decide on the value of a certain policy. The next piece of this chapter goes into another sort of controversial piece of determining the value of a policy, and that is valuing human life. So a lot of times the cost of an externality, the cost of pollution, or the cost of anything that degrades any environmental resource is a cost to health or human life. And so if we want to truly evaluate the value of a policy that, say, reduces pollution, we need to understand then what is the value of the human life that we might save. if we do that. And it's certainly controversial. It doesn't feel good to put a dollar sign on the value of human life, but sometimes it's necessary to be able to really do a cost benefit analysis of a policy. There are two main ways that we can do this, and one is just to ask people. So ask, for example, the question, how much would you be willing to pay for a policy that would improve air quality so the number of people who die from pollution would be reduced by 50 per year? And you get people's answer to that, and you can figure out what people are willing to pay per person who dies, right? You don't tell them a specific, you don't say if your grandma were to die, right? What if a policy would keep your grandma alive? Because then you'd get vastly different numbers. But we just say 50 fewer people would die, and the assumption there is that could include your grandma. Um, Obviously, you can read more about the sort of the controversy that goes into really both of these two ways to measure value, but obviously there's some problems with that way of measuring value. The other way that we do it is through a wage risk analysis, and this is more of a sort of economically friendly or economics friendly method, because it uses data and it uses people's real behavior rather than just asking people a question that's sort of hypothetical. And this is, we can look at different jobs across the spectrum of all the jobs, and some of them clearly are riskier than others. So some jobs, coal mining, for example, military, for example, some jobs involve higher risk of injury or death. And so what we should see is that those jobs, if we control for other things, right? And we can do that using some fancy statistics. If we have two jobs that are identical except for the risk of one is higher than the risk of the other, we can look at what wage people in those jobs accept, and we should theoretically see that it takes more money to get people to do the riskier job, right? So you can think about doing identical work. So, for example, military work. So you're doing identical work, but you're sitting in a chair and doing it using a virtual reality machine where you can't actually get injured versus doing it actually in the field, right? If you're actually going to the field versus sitting in front of a virtual reality machine, then you're going to require extra money for that. They're going to have to pay you for that extra risk of actually getting injured or killed, right? And so we can look at this. We can look at how much extra money people get paid to do extra risky jobs, um, and we can sort of extrapolate from that. We can assume from that what safety, what life is worth to people. So that's another possible way, really more common way of valuing human life, but again, also controversial. Um, Then, when we're thinking about cost benefit analysis, there are certain costs or benefits that we're not sure if they will happen. It's a possible cost, it's a possible benefit. So, if you think about this example, this table shows numbers for building a dam. And the costs and benefits of that dam are different depending on how much rain we get. If we get a lot of rain, then the benefit of a uh, a dam may be lower than if we don't get as much rain, because the dam may break or flood, right? If we don't get much rain, then the benefits of a dam also may be lower because we didn't really need the dam to start with, or it doesn't provide as much electricity, or whatever the reason for building the dam was. So notice here in this table, we've got the benefit of the dam if we have low precipitation, and the probability that we will have low precipitation. So we can look at weather histories and forecasts and things and figure out how likely are we to have low precipitation. And the answer in this example is 27% of the time we might have low precipitation, right? And they do that for each of the types of or levels of precipitation. If we get average precipitation, then the benefit of the dam is $10 million to us. There's 0.49% chance that we'll have that, right? So on down the table, and then we assign what's called an expected value to the benefits or costs of the dam. based on the different precipitations. So we don't know which level of precipitation we might get. We just know the probabilities of them. And so what we do to figure out what our expected benefit is, or another word for that is the average benefit that we think we'll get from the dam, given the possibility of different levels of rain, we take the benefit and multiply it by the probability. And then we get an expected value. So you take this column times this column, and you get the expected benefit, or the probable benefit from low precipitation, right? And then we have the probable benefit from average and the probable benefit for high, and you add all of those up. So this very last row is the total expected value, the expected or average expected benefit from the dam. Is take each scenario, multiply it by the probability that it will happen, and then add all those up. The last piece of the chapter goes through an example of a cost-benefit analysis. I encourage you to look at that example, take some time noticing how all of these different costs and benefits are calculated, how they go together. If you're really interested, Chapter 7's appendix is actually really nice. It teaches you how to do some of these calculations using Excel, which can be helpful on homework, but also in work in your career. If you're ever asked to do a cost benefit analysis, knowing how to do these things using technology is super helpful. You don't have to do pen and paper for every single calculation when there's tons of them, specifically those present value calculations where you may want to know the present value of something 99 and 100 years from now. That's 99 or 100 calculations. So knowing how to do that in Excel can be super useful. And that's the appendix of this chapter. But definitely go through the last section where they go through this example of cost benefit analysis for dam construction. And then if you want, I really encourage you also to take a look at the appendix.